All right, in this lesson, we're going to talk about inverses of logs and exponential functions. And so I want to start actually doing it graphically because we just talked about how to graph log functions. And so looking at the second page, number 7, they have graphed log base 2 of x for us. And so we can see that he's got a vertical asymptote at x equals 0. His first point is his x-intercept is 1 away from the vertical asymptote, and his second point is the base away, which in this case is 2. And so we have 3 good points here, and so to graph the exponential, we just need to take those points, and so I'm going to put them in a table, 1, 0, 2, I guess that's 1, and then 4, 2. And so for the inverse function, the x and y's just switch. You always just switch the x and y. And so this notation should really just be f of x and f inverse of x. That -1 on a function, not a variable, but on a function means inverse. And so that's what they're trying to say here is the inverse. And so we're just going to switch the x and y's. Don't change any signs, just switch their places. And so that gives me a new set of points for the inverse function. And so this is the original function. And so now I'm going to graph the inverse function in red. So we have the point 0, 1. It's a y-intercept. And then we have the point 1, 2. And then we have the point 2, 4. And so this function is growing, doubling as we go to the right, and then it would be getting cut in half as we go to the left. And so we recognize that as exponential. It's got a horizontal asymptote at y equals 0. And it is growing, it is doubling. And so that function would be, let me use this notation. If I needed to write the function, it would be 2 to the x power. And so that makes sense. If we have log base 2 of x, his inverse is going to be exponential base 2 to the x power. And so something else you'll notice is that anytime you're dealing with inverses, it doesn't matter what kind of function you're dealing with, they're always going to be reflected across the slanted line through the origin. This is the y equals x line. And so they should always be mirrored across that line. So if you need to determine graphically if something is an inverse, you just need to check to make sure that's true. And so we can do this next problem and graph them and see if they are reflections. So I'm going to start with graphing the log function since we just graphed those. And so this is log base 3, but he's been moved right 5, up 8. Okay, and so usually his vertical asymptote is at x equals 0. But if we move that right 5, that is now going to be right 5 at the 5, 2, 3, 4, 5. So there's our new vertical asymptote. And then we would have a point that's 1 away and then base 3 away. But these points, I've already shifted them right 5. They now have to move up 8 units. So I'm going to take these 2 points and shift them up 1, 2, 3, 4, 5, 6, 7, 8 units. Okay, and so there's our log function. Up to the right, down towards the asymptote. Now for exponential, we know they have a horizontal asymptote at whatever this number is. Y equals 5. So 1, 2, 3, 4, 5. And then usually they have a y-intercept that is 1 away. And then the next good point would be the base away. So in this case, 3 away. And it would be growing to the right. But we need to shift those. We've already shifted them up 5 units. We also have to shift them right 8 units. So I'm going to take this y-intercept and move it to the right. And then the point to his immediate right is going to be 3 away from the asymptote. And so you can see these functions are reflections across that line. And so yes. And then as we write the domain and range, starting with the red function, the exponential, his domain, we know domain of exponential is all real numbers all the time, negative infinity to positive infinity, forever to the left, forever to the right. And then the asymptote is now at y equals 5. And he is above the asymptote, so 5 to infinity. For the log function, the domain starts at this vertical asymptote, so starts at 5. And then this function is to the right of the asymptote, so it's going to infinity. And then logs have a range of all real numbers. So something you'll notice about domain and range, they're always flipped. So if you have the domain and range of one function, you automatically have the domain and range of the inverse. You just switch the domain and range, which makes sense because all the x's and y's switch. Okay, and so that's how you would find the inverse graphically, just switch the x and y's in the table. Algebraically, you do the same thing. You switch x and y and then just resolve for y. So starting with the left side, we're going to solve for the inverse of these 3 log functions. And so the inverse of a log is always going to be exponential, and it's going to have the same base. And so you can already kind of picture that you're going to have an exponential function with base 2. Okay, and so first step, switch your x and y. And then we have to resolve for the y variable. And so our first step is to add 1 to both sides, isolate the log, and so that gives me x plus 1 equals log base 2 of y plus 5. Now that we've isolated the log, we're ready to convert. This is the step where you convert to exponential. And so your base is 2 to the x plus 1 power equals y plus 5. 2 to the x plus 1 power equals y plus 5. So remember, we're trying to solve for y, and we're almost done. We just need to subtract that 5 from both sides. And so when you subtract 5 from both sides, make sure you don't put it up in the exponent. And so our final answer is going to have y by itself. You're going to have 2 to the x plus 1, and then minus 5 outside the exponent. Okay, looking at number 3, switch your x and y. And then we are re-solving for the y. And so here, the log is already isolated. There is nothing in front of the log. There is nothing being added outside the log. So here, we are ready to convert. And so we would have base 2 to the x power equals y minus 4. So 2 to the x power equals y minus 4. And now last step, we just add the 4 to both sides. And so we get y equals 2 to the x plus 4. So bad x. So final answer, 2 to the x plus 4. Right, next up, we're working with natural logs. So remember, that's base e. And so first step, switch your x and y. And then we have to isolate the log. So we need to subtract this 4. And now we're ready to convert. So if if you want to put in the e to the x minus 4 equals y. And we're done. Y is isolated. So e to the x minus 4. So a pattern you might notice, and a good way to check your work, is that your inverses will always have the same base. One will be log, one will be exponential. And then if you have a minus 1 outside the log, you're going to have a plus 1 inside the exponential. If you have a plus 5 inside your log, you're going to end up with a minus 5 outside. So they switch signs and switch places as you rewrite the equation. And so here we had a minus 4 inside, so it makes sense that we had a plus 4 outside. Here we had a plus 4 outside, ended up with a minus 4 inside. Okay, and so looking at going in the opposite direction, we're starting with exponential, and then we're going to end up with logs. And so I can already kind of visualize I'm going to end up with a log base 2 over here. I'm going to end up with a log base 3 over here. And I'm going to end up with natural log over here. Okay, so first step, switch your x and y. And you don't have to have parentheses around the exponent. Subtract 4 from both sides to isolate the exponential expression. And then once you have the exponential expression isolated, meaning there's nothing outside the exponent like that plus 4, you're ready to convert to log. And so we have base 2 of x minus 4 equals y minus 5. So log base 2 of x minus 4 equals the y minus 5. So almost done. Our last step is just to add this 5 to both sides. Make sure it doesn't go inside the log. It can't go inside the log late. Can't join late. So that plus 5 has to stay outside. Okay, and so our final answer is log base 2 of x minus 4 and then a plus 5 outside. And so to kind of check our work, we have the same base. Our minus 5 inside became a plus 5 outside. Our plus 4 outside became a minus 4 inside. All right, next up, switch your x and y. And then resolve for the y. So first step, subtract the 5 to isolate your exponential. Now we're ready to convert. Base 3, log base 3 of x minus 5 equals y minus 8. Log base 3 of x minus 5 equals y minus 8. Last step, add 8 to both sides. Don't put it inside the log, can't join the log late. And so our final answer is log base 3 of x minus 5 plus 8. Double check. Our base is still base 3. Our minus 8 inside became plus 8 outside. Our plus 5 outside became a minus 5 inside. All right, last one. Switch your x and y. Isolate your exponential by adding 9. Now we're ready to convert. Log base e, which is natural log, of x plus 9 equals y. And so we have e as the base, and then natural log, which has e as his understood base. A minus 9 outside became a plus 9 inside. All right, the last thing we're going to talk about is how to verify using function composition whether or not something is an inverse or not. And so function composition, remember from unit 1, you're putting one function inside of the other. And so if I'm doing f of g of x, f is this exponential function here. And so wherever I had the x, I'm going to put g of x in his place. And so that function would now be 3 raised to the g of x minus 8 plus 5. And so that means g of x, which is log base 3 of x minus 5. And then we still have the minus 8 up in the exponent with him. And then a plus 5. Or, sorry, I didn't finish writing that function. It was log x minus 5, and then there was a plus 8 at the end. And then we have this minus 8, and then the big plus 5 outside. And so now I call it the cancellation game. Things cancel, but in order. The first things that cancel is this 8 and the negative 8 right off the bat. And so from there, you want to rewrite your next step. You don't want to cross too many things off. This is kind of like writing a proof. So you got to write out each step. The next thing that cancels is these 5s can't reach each other. But we know that exponential base 3 and log base 3 cancel. And so that expression would just leave the x minus 5 by itself. And then we still have the plus 5. And now the 5s can reach each other. And so when we plug g of x into f of x, it ends up just being x again, showing that these functions undo each other. And so that's one direction. We need to show that if we put f inside of g, they would also equal x. So this time we're putting g of x inside, that's not it. No, we're putting f of x, sorry. We are putting f of x inside g of x. So we're replacing this x with f of x. And so we can simplify log. I think this was supposed to be a base 3. That was a typo. So log base 3 of, and then let's go get the rule for f of x, which is 3 to the x minus 8. And then a plus 5 outside. And then we have this minus 5, close parenthesis, plus 8. So right off the bat, the 5s cancel, leaving us with just a 3 to the x minus 8. Now these 8s can't reach each other, but log base 3 and exponential base 3 cancel, freeing up the x minus 8. And now the 8s cancel, leaving just the x. Check, check. Okay, so let's do one from the top. And so let's do f of g of x first. And so f, let me use black. F of g of x equals log base 2 of, and then I'm going to leave a blank where x was. Leave a pretty big blank. Because we're going to put g of x in his place, which is 2 to the x plus 4. And so right off the bat, the 4s cancel, leaving me with log base 2 of 2 to the x. And then the 2's cancel. Log base 2, exponential, leaving me with just the x. Going in the other direction, g is the outside function. F of x will be the inside function. And so g of x is 2 to the x with a plus 4 outside. And so where x used to be, we're putting in f of x, which is this log function, log base 2 of x. Let me get rid of those. Minus 4. Okay, and so the only thing that cancels right off the bat is this exponential base 2 and the log base 2, which just leaves the x minus 4 part. And now the 4's cancel, leaving me with just